Hi guys, welcome back. We haven't done this in a while. We are going to be we've been using the Elmo recently, so we're going to be going back to PowerPoint just for a little bit, but we will go back to the Elmo. So let's go ahead and get started. I hope everyone's having a good day. I know it's a couple of trying days, but let's just hang in there. And if you need anything from me, just go ahead and hit me up, and I will be most definitely there to help you out with anything you're going through. All right, so today we're going to learn to differentiate between excited and ground state by analyzing electron configurations. Here we go. Here's our agenda. We're probably not going to get to the simulation, but that's fine. We'll do a couple of experiments to help us out with those in the coming days, or we'll view a couple of experiments considering. All right, so these two images depict ground and excited state. So ground state, I want to see what are you noticing between the two. What are you noticing between ground state for neon and excited state for neon? So one thing that I notice is that neon has 10 electrons based on the electron configuration. I just add those two numbers up. And for ground state, but it also has 10 electrons for electron configuration for excited state. So the number of electrons is not changing. What is changing that I'm noticing is that I gain one more orbital. I gain one more orbital, and one electron, I can see that one electron from the second orbital in the ground state has gone to a third orbital in the excited state. So if you've noticed these observations, that's great. So let's go ahead and let's define what excited and ground state is. So ground state is electrons in the lowest energy configuration possible. This is an electron configuration that you can find on the periodic table in your chemistry reference table, right? So for example, the ground state for lithium, the ground state of the electron configuration for lithium is 2,1. This is what I see on the periodic table. Now, the excited state is electrons that are found in a higher energy configuration. Basically, any electron configuration that you don't see on the periodic table. So, for example, lithium, an excited state for lithium would be 1,2 or 1,1,1, where I can see an electron has jumped from the first energy level to the second energy level, or I can see an electron has formed a third energy level. All excited, right? So, let's see if we can recognize excited and ground state. I want you to take a few moments. Go ahead, pause this, and see if you can determine which electron configuration is excited or ground. One thing I'll let you know is that the electrons can never exceed how much the shell can hold. So if the energy level is supposed to only hold 2 electrons, you'll never see 3 electrons in that energy level. So that's why we see on the first shell, all of them hold 2. So the first energy shell can only hold 2, the second 8, the third 18. So you'll never see it exceed the number that it can hold. If it does exceed, that's obviously a wrong configuration, right? So go ahead and pause and answer these questions and then come right back. If you join us during the live session, we will go over this, but go ahead and pause and come right back. So I see that you're back. So some of you might be wondering, okay, so I understand ground state, I understand excited state, but how do we go from ground to excited? Very simple. Very simple. And I'm going to use, hopefully, I can use a colored pen to explain something, right? So when ground state electrons absorb energy, so this electron right here, when it absorbs energy, so that's my energy, and let's say that energy is a photon, it's usually a photon. So that's my energy. When it absorbs energy, right, our electron gets excited. It absorbs that energy and it jumps, because it gets excited, it jumps to another energy level. Now, while it jumps to that other energy level, it's unstable, it's temporary. So meaning that it can't stay there for long. It can't stay there for long. So when it does fall back down, right, or it drops to a lower energy level, and when it drops down to a lower energy level, the energy that it absorbed leaves, right? So energy that absorbs leaves. And then when that energy leaves, it leaves in the form of light. So that light ends up producing colors for specific elements and the bright light spectrum. The bright light spectrum is and the color for the specific elements are known as the chemical fingerprint. It's very specific to each element. So you'll notice that for sodium, sodium will release a certain bright light spectrum that no other element will release, or it will produce a yellow light that no other chemical can produce, right? So this is what happens when our excited electron drops back down to ground state. So let's go ahead and summarize that just a little bit. So when we go from ground to excited state, energy is absorbed. That's basically us going from like level 1 to level 2, right? And we had this dark line spectrum produced. Dark lines show the specific wavelengths of light being absorbed by the electrons. So anytime we see these dark lines, that is when the electron, that's where the light is being, that's where the energy is being absorbed. That's where the electron becomes excited at that specific wavelength, right? Then when we go from excited to ground, that's basically us going from level 2 to level 1. Energy is released. This is where we produce the bright light spectrum. The bright light shows the specific wavelengths of light being released by the electron. So when we go from excited to ground, we absorb energy. We produce dark line spectrum. When we're going from excited to ground, energy is released. We produce the bright light spectrum. Right? Now we're going to be able to read bright light spectrums. So let's see if we can do this problem together. And this is a bright light spectrum. Usually it comes in a color. When you see it on the chemistry side or the chemistry reference table, you'll notice it in black and white. However, in the lab that you'll see in a couple of days, we'll give you the color version. So let's see if we can answer this question. Based on the known bright light spectra produced by the 4 gases below, which gases are present in the unknown mixture? Now, what does your mind automatically want to do? If you said line up the lines, that is exactly correct. All you have to do to solve this problem is to line up the lines. So by lining it up, you can use a pencil like I'm going to do here. See which one follows the same one. Usually, what makes up an unknown is 1 to 2 gases or elements, or sometimes even 3. It depends on the substance, right? But it's never just 1, and it's never just all of them. So never 1, never all of them, most likely 2 or 3. So, for example, by looking at this, I can tell you that gas A is already present because the 3 lines are there. Do I see gas B? Well, these 2 lines are here, but those 2 lines are not present. All the lines must match up. It just can't be 1. All of them must match up. So gas B is not present in my unknown. Let's see, D does not have this line here, and it doesn't have those 2 lines there either. So it can't be C either. Let's go to D. Well, this line matches up, and these 2 lines matches up. So the gases are going to be in my unknown, A and D. We're going to be practicing this a whole lot more tomorrow when we do our bright light spectrum lab and flame test lab. So be prepared for that. If you have any questions, please come during the live session, and we most definitely will help you out with this. We know it's a far-fetched concept, but you need to realize by the end of this that electrons do move. Electrons move around their orbitals. Electrons are able to be transferred. Electrons are able to be shared. Electrons are what make chemistry chemistry. Most of our actions, most of our chemical bonds, most of our explosions, most of our reactions happen due to electrons. So this is just the start of noticing that electrons do change and electrons do move and produce different types of reactions. All right, I'll see you guys next time, and hopefully you have a great and peaceful and relaxing day.